Imagine this. You're gazing up at the night sky, stars twinkling like distant whispers, when suddenly something streaks across the void. Not from our neighborhood, but from the endless dark beyond. It's cold, it's fast, and it's here. What if this visitor isn't just passing through? What if it's the key to unlocking secrets we've chased for centuries? Buckle up because today we're diving into the story of 3I/ATLAS, the third confirmed interstellar comet to grace our solar system. If you're ready to question everything you thought you knew about the cosmos, hit that subscribe button now and turn on notifications. You won't want to miss what comes next. Let's start at the beginning, where it all flickered to life. On July 1st, 2025, astronomers at the NASA-funded Asteroid Terrestrial Impact Last Alert System, ATLAS for short, in Rio Hurtado, Chile, spotted a faint blip in their data. This wasn't your average asteroid hunt. ATLAS is designed to scan the skies for potential threats, like rocks that could slam into Earth. But this object, initially labeled A11PL3Z, stood out immediately. It was dim, with an apparent magnitude of 18, barely visible even to powerful telescopes, but moving in a way that screamed outsider. Follow-up observations poured in from around the globe. By July 2nd, with data from 31 observatories and 122 measurements, the International Astronomical Union confirmed it. This was no local wanderer. It was interstellar, the third of its kind ever detected. We call it 3I/ATLAS now, or C/2025N, 1ATLAS in comet nomenclature. Pre-discovery images push the timeline back further. Archives from Atlas telescopes and Caltech's Zwicky Transient Facility at Palomar Observatory revealed glimpses as early as May 7, 2025, when it was still lurking far out, about 4.5 astronomical units, AU, from the Sun. That's roughly 420 million miles away, beyond Jupiter's orbit. Picture the excitement in those observatories. Teams scrambling, emails flying, as the data painted a picture of something barreling in from the constellation Sagittarius. For context, our first interstellar visitor, 1I/ʻOumuamua, was discovered in October 2017 by the Pan-STARRS telescope in Hawaii. It was a rocky, cigar-shaped oddity, about 400 meters long, tumbling through space without a comet's telltale tail. Then came 2I/Borisov in August 2019, spotted by amateur astronomer Gennady Borisov in Crimea, a more traditional comet, gassy and active, with a nucleus around 1 kilometer wide. Now 3I/ATLAS joins the club, but it's already proving to be a bridge between the two. Icy like Borisov, yet with quirks that echo ʻOumuamua's mysteries. This discovery didn't happen in isolation. It builds on decades of skywatching tech advancements. Systems like ATLAS, which scans the entire visible sky every 2 nights, have made it possible to catch these rare interlopers. Before 2017, we'd never confirmed one. Space seemed vast and empty. Now in less than a decade, 3 have shown up. Is it luck, better tools, or something more? We'll circle back to that. For now, know this. 3I/ATLAS was clocked at about 137,000 miles per hour, 221,000 kilometers per hour, or 61 kilometers per second, upon discovery. That's faster than any solar system object at that distance. A dead giveaway, it's not from around here. Now let's zoom in on what this thing is made of, because here's where the drama really builds. Early observations showed 3I/ATLAS wasn't just a dead rock, it had activity. By July 2nd, astronomers spotted a coma, a fuzzy envelope of gas and dust surrounding the nucleus, and hints of a tail. This classified it firmly as a comet, not an asteroid like ʻOumuamua. The nucleus itself? Estimates vary, but Hubble Space Telescope images from July 21st, 2025, peg it at less than 1 kilometer in diameter, with an upper limit of 3.5 miles, 5.6 kilometers. Some early guesses went as high as 7 miles, but refined data narrowed it down. It's small, but potent. The James Webb Space Telescope, JWST, turned its gaze on August 6, 2025, using its near-infrared spectrograph (NIR spec) to dissect the light it emits and reflects. What JWST revealed is fascinating. 3I/ATLAS is rich in carbon dioxide, CO2, with one of the highest CO2 to water, H2O, ratios ever seen in a comet, around 8.1. That's factual, pulled from spectral analysis. It also shows traces of water vapor, carbon monoxide, carbonyl sulfide, cyanide gas, and even atomic nickel vapor detected by the Very Large Telescope in Chile. These are similar to what we see in our own solar system's comets, like those from the Oort cloud. But the CO2 dominance is standout. Why does that matter? Comets are time capsules, preserving materials from their birth systems. A high CO2 content suggests 3I/ATLAS formed in a protoplanetary disk where CO2 ice was abundant, perhaps farther from its parent star or in a system bombarded by more cosmic radiation. Observations from Gemini South and the Nordic Optical Telescope show a reddish hue to the coma, with high negative polarization in the light scatter, hinting at a mix of icy grains and darker, organic-rich dust. But here's a twist. 3I/ATLAS started out gassing and forming its coma unusually far from the sun, beyond 5 AU, where solar heat shouldn't be enough to melt ices. Most comets wait until closer, like 3 astronomical units or less. This early activity, it's observed fact, captured in images showing the coma growing to 26,400 by 24,700 kilometers by late July. No outbursts or fragmentation noted yet, just steady brightening. Separate from these facts, some speculate this CO2 richness or early activity could point to unique formation conditions, or, in wilder theories, something engineered. But stick with me. We'll tackle debates later. If the composition is the what, the trajectory is the how and where, and it's a nail-biter. 3I/ATLAS is on a hyperbolic orbit, meaning it's not orbiting the sun like our planets or comets. Its eccentricity is a whopping 6.14, far above 1, the threshold for closed orbits. This path is almost straight, like a bullet grazing through our system. It entered from the direction of Sagittarius, possibly the Milky Way's bulge, though its exact origin is unknown. Could be from another star system light years away, traveling for millions or billions of years. At perihelion closest to the Sun, on October 29, 2025, at 136 astronomical units, it'll hit a peak speed of 68.3 kilometers per second, about 153,000 miles per hour. That's when it'll be brightest, potentially visible to amateur telescopes. Post-perihelion, it'll swing past Earth at a safe 1.8 astronomical units, 170 million miles, on December 19, 2025, then head out, escaping the sun's gravity by mid-2026. Close calls? It'll skim 0.0179 astronomical units from Mars on October 3rd, brush Venus on November 3rd, and pass Jupiter. NASA's Juno spacecraft orbiting Jupiter might get a peak if trajectories align. This retrograde motion, inclined just 5 degrees to the ecliptic but going opposite our planets, adds to the intrigue. It's like a ghost ship sailing against the current. Factual tracking shows no major deviations yet. It's following predictions based on gravity alone. But that flat, fast path, it makes you wonder about the forces that flung it our way. All right, let's lean into the what-ifs. But remember, I'm drawing a clear line here between facts and theories. Factually, 3I/ATLAS gives us a rare window into another star system. Its chemistry, like the high CO2, could imply differences in how planets form elsewhere, maybe more carbon-rich worlds, or ones with thicker atmospheres. Studying it helps refine models of exoplanet systems, and with JWST's data, we might learn about interstellar chemistry, like how radiation alters ices over eons. On the implication side, if more such objects keep appearing, 3 and 8 years after 0 for centuries, it suggests interstellar wanderers are common. Estimates from ʻOumuamua's discovery peg thousands passing through our system at any time, mostly undetected. Better telescopes like JWST and upcoming ones like the Vera C. Rubin Observatory could spot dozens more. Speculatively, this could reshape planetary defense. Atlas caught it early, but what if a faster, larger one aimed at Earth? It underscores the need for missions like NASA's NEO Surveyor. Environmentally, comets like this might have seeded life-building molecules across the galaxy. Panspermia theory in action. Now the heated part, debates raging in labs and papers. One big one is origin. Facts show it's interstellar, but where? Some models point to ejection from a binary star system or a close stellar encounter. The high speed suggests a dynamic birthplace, perhaps near the galactic center. Then there's the artificiality buzz. Early on, when it seemed to emit its own light far out, whispers of alien tech surfaced, echoing Harvard's Avi Loeb on ʻOumuamua, where he proposed solar sails causing non-gravitational acceleration. For 3IATLAS, a controversial preprint floated extraterrestrial technology. But experts like Northeastern's Jacqueline McCleary dismiss it. Observations confirm it's a natural comet, with outgassing explaining the activity. No unexplained acceleration detected. It's all gravity and solar wind. Debates also swirl around composition. Is the CO2 ratio due to radiation stripping outer layers or inherent to its birth? SphereX and JWST data lean toward the latter, but analysis is ongoing. Critics argue it's not that weird. Some solar comets have high CO2 too. The key? More data as it nears perihelion. Beyond Science, 3I/ATLAS taps into our collective psyche. In a world of AI booms and Mars missions, it arrives like a cosmic postcard, reminding us we're not isolated. Culturally, interstellar objects fuel sci-fi, from Arthur C. Clarke's Rendezvous with Rama to modern takes like Project Hail Mary. They've sparked art, memes, and even stock surges in space tech. Public reaction? Excitement mixed with unease. Social media buzzed with alien theories, but agencies like NASA emphasize education, hosting webinars, releasing images to demystify. It highlights global collaboration. From Chile's ATLAS to Europe's VLT, it's a shared human endeavor. In uncertain times, it inspires wonder, pushing us to look up and dream bigger. As 3I/ATLAS hurtles toward its solar rendezvous, we're left with a universe that's richer, stranger, and more connected than we imagined. This isn't just a comet, it's a messenger from the stars, carrying clues to our origins and the galaxy's secrets. We've peered into its heart with JWST, measured its dash with Hubble, and now we wait for what October reveals. Whether natural wonder or cosmic coincidence, it proves space isn't silent. It's speaking if we're listening. If this journey through the stars left you breathless, smash that like button, subscribe for more cosmic adventures, and turn on notifications, because the next visitor could change everything. Share this with a friend who stares at the sky and wonders. Stay tuned. The universe has more in store. What do you think? Is 3I/ATLAS just a quirky comet? Or could it be hinting at something bigger out there? Drop your thoughts in the comments below.